Today I'm going to talk about my research work on graph analysis and graph search in networks. So basically this reflects two research themes conducted in my lab. One is graph analytics, one is recently graph search in knowledge graphs. So I think I don't need to convince you how important the graph is. Everyone in this world is connected. If we just take a protein structure as an example, like protein structure itself is a graph. And the protein interact with each other, formulate a protein interaction network. Eventually, it builds the physical bodies like us. And we actually are connected in social networks. So it is very important to study how to manage, model, and mining various kind of graphs. And we have been working in this area for a long time. And one question is whether they're done. Unfortunately, there are more issues to address with the emergence of new kinds of graphs. So there are several major challenges in the graph mining, graph search community. The first one is for graph analytics, for various kinds of networks, whether there's any commonality existing in different graph analytics routines. And if we can find those commonalities, then we can develop algorithms to build this commonality, build the infrastructure so that we can reuse those components again and again to build more advanced algorithms. Second challenge is nowadays graph becomes more and more complex. Not only we have the topological structures of the graph, we have more and more content, attributes, labels associated with nodes and edges. And these rich contents, actually reflect the semantics of the graphs. And furthermore, we have temporal graphs, and our graphs often change, like the dynamics of graphs. How to store and how to index, how to search those temporal graphs is open research question. And furthermore, there's a heterogeneity existing in large scale, for example, knowledge graphs. And the schema becomes more and more complicated. And the schema might not be consistent across the different portions of knowledge graphs. And how can you develop a kind of query engine which can handle the heterogeneity of large graphs? No one knows how to do that. Okay, but today I will talk about our recent progress in this domain. And of course, scalability, like we are talking about big data, big graph data. Like scalability is always an issue, right? You have a large scale graph, even for very small graph, if your graph analytics becomes very complicated, then the algorithms will take a long time to finish. So how can you develop some kind of fast algorithms which can help us to handle those large scale graphs? There are many open questions. And recently, as we know that artificial intelligence, especially neural network deep learning, achieve great success in various kind of tasks. You can view neural networks as a kind of graph, and you can guess that connections embedded in those neural networks actually mean something related with knowledge. And how can we leverage these recent advances of neural network to further improve the data mining and machine learning in graphs? It is an open question. So there are many research opportunities in this domain. First one is like how can you develop or identify new types of graph search and mining operations so that these operations becomes very fundamental. We can reuse these operations again and again. Second, how can we develop good graph query language so that we can query various kind of knowledge graphs built from different sources? What kind of query engine we should develop? Whether we should just rely on the traditional relational query engine to answer graph queries. The third one is large-scale graph processing. This has been, I cannot say well done, but has been extensively studied. We have seen distributed graph processing systems like Prego, like Giraffe, like recently GraphX that is built on Spark. And how can you process large graphs divided into multiple pieces and distributed in different machines? And furthermore, above that, can you build some kind of analytics routines or query engine so that you can run your query in parallel across multiple machines? That is very interesting. And the knowledge graph, I will specifically spend 20 minutes talking about our recent progress in querying and searching knowledge graph. That is very important, especially nowadays we rely on natural language query interface to access our mobile devices. And many killer applications are emerging. So these are very exciting topics in our domain.